Okay, making some progress here. Again, I have 2,000 watts rated of lights, 4 500 watt halogens in parallel. Not saying that's 2,000 watts, but it's up there, maybe 1,500. Every time it goes on, I have the cooktop in 3, which is a low power setting, and it makes the lights turn on and off, which is, I like that. So I have time to fiddle with the wiring while it's off. Like right now I could hook up some stuff. But anyways, what I got going is this transformer I made of 18 gauge speaker wire, and it's got a big ferrite core in the middle of it, and it's bifilar, and I have it hooked up with it parallel across the lights. It's just real simple. One wire on one side of the lights, one wire on the other side of the lights, one wire here, one wire here. That's what's feeding this transformer. Out of this transformer are these ultra-fast diodes, and they're not getting hot. It's so nice to see. I got burned badly before some other experiments. These are 600 volt rated at 30 amps ultra-fast diodes. Let's see if you can see the number here. Whatever. You can buy them, just put in 600 volt 30 amp ultra-fast diodes. So that's a full wave bridge rectifier. It makes it into DC. And coming out of the full wave bridge rectifier DC side, I put it into a 6 UF 800 volt capacitor. This is an AC type, but it's being fed DC, and look what I'm getting out of here. If I leave it on without it flashing, I'll turn it up. I'm just going to leave it on. It's getting close. My target's 175 volts. But it's getting close to what I want it to be. See, because I turned it up, the lights just stay on. So it's about 155 volts, and actually the full wave bridge rectifier inside of here, you know, so I've explained it's fed 120 volts from the grid, and then they have a filter cap and a inductor and stuff, and then it goes to a full wave bridge rectifier underneath this heatsink, and it converts it to DC, and that DC is about 175 volts without a load, and that's what gets chopped at 24,000 million times a second, 24 kilohertz, and powers this primary coil down here. This, and it's not a bifilar, it's just a flat coil with none of the spacing there. The stock primary coil you'll see in one of these cooktops, and it has these ferrite bars underneath. So on top of that primary coil sits this stack of bifilar series 80 coils. And you just get a little bit warm. Hot, not hot, just a little warm. anyways, that full wave bridge rectifier that converts the 120 volts into DC, I soldered these two wires to the DC side. So this is 175 volts DC. If I turn it off, if I have it on, it's 152 volts. The resistance of that coil, powering that, shooting 24 kilohertz, 175 volts into this primary coil down here, makes it 152 volts. So if I check it, it's going to be 152 volts. And so what I want to do is take what's coming out of those lights and run it into here, the DC side. And so I need to get that voltage at 175 volts DC to pull this trick off. And I actually going to have two of these, one here and one here, and I'm going to just try and run another one from this first. And into its full wave bridge rectifier. If I can pull that off, that will be quite a big jump. And I think I can. I just need 175 volts DC coming off these lights. So, what's happened here? So here we go. What do we got? 155 volts continuous into this cap here. Now, if I disconnect this cap, like I just did, it's only 83 volts. But I put this cap here, that would be 83 volts coming out of the full wave bridge rectifier with no cap. But you hook this cap up and now you start getting up what you want to get. Pretty close. This might even work the way it is. Maybe I don't need 175. Now I'd like to put a DC type cap here of high voltage type. And I was fooling around with putting a 5 UF cap like across the AC feed to it, across here, parallel 5, and it would cut the lights bright down a lot. Also, this is drawing about 6 amps from the grid right now. I'm going to put this back down on. None of this stuff makes the draw go up. There's so much isolation from the primary coil and the IGBT circuit pulsing in and everything. There's so much isolation with that transformer, that transformer, that nothing seems to kick back and make the draw go up, except raising the power level here. Now down here at 3, I think it's going to be more like 5. So maybe a little less than 6 amps. So, kind of happy with this. I think what I should do, my next step is find a high voltage DC cap, not AC, so it kind of stores it better. And I can play with the windings. I just got some more of this speaker wire today. I can wind another coil and have it step up a bit. So we got about 175 here. I was hoping I could get the voltage up by putting caps in series, but that wasn't working. Maybe I can still do that and find the right cap. Tune it with caps. But I'm close to the target voltage with a cap on the DC output of the 4-wave bridge rectifier. So this is pretty good, and nothing's getting hot. These are nice and cool. And remember, I'm going parallel to the lights into the transformer. You'd think it would kick up the power input, but it doesn't. Doesn't seem to reflect. Okay, well, there's my latest progressions or progress. This is my circuit here. When I get around to it, I'm going to be getting rid of this cooktop and send in power with a chip chopping up a probably from an inverter, and then it's going to get chopped at 24 kilohertz by this, and has pulse width adjustment too, so I can use pulse width adjust to make the draw even less, and maybe it'll still be the same or better output. Okay, well, thanks for watching.